Welcome back to my channel. The subject we are going to discuss today is anomalous expansion of water. You may be thinking, what has anomalous expansion of water got to do with quantum mechanics or relativity or anything that we usually discuss? So, the reason why I wanted to discuss this today is that generally how any of the chemicals or organic or inorganic compounds behave, the density of what? Uh, Generally, things contract when you cool them. When you cool a gas, it contracts and its density becomes small, right? But when you cool water, then the density of water eh, increases till density of water increases till 4 degrees centigrade. If you cool it further, what happens is if you go, let's say, 3 degrees, 2 degrees, 1 degree, 0 degrees, what you naturally expect is the density to be highest here. But the density of water, that is actually wrong. The density of water is highest at 4 degrees centigrade. So that is why it is called anomalous expansion of water. It's abnormal expansion of water. Now, so why I'm telling you about this? The same thing, the same principle holds good in basically the quantum and relative realms. Actually, quantum and relative, what do you call the, we can say, border of these two. At this border, quantum and relative border, when these two realms separate, there, if you watched any of my previous videos, I always talk about number 119 and its significance related to Planck's constant. How it is related? H is equal to 119 m by c, where m is mass of proton and c is scalar light, of course. Right? So when this number 119, in the last video, watch my previous video. In that, I explained that the uh, Periodic table. Periodic table, while explaining the significance of number 119, I explained that the periodic table starts with 1 and ends with 118. So this 119, uh, of course, 1, 2, 3, 4, 5, 6, 7. So these are the periods, right? 7 periods. Here we had 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These are 18 groups. Periods go down, groups go from left to right. So at 118, the present table ends. And I also told that 119 is like proton, 120 is like neutron, and 121 is like atom. That's not hydrogen atom. So, yeah, we were talking about enamels, right? So, from the beginning, I have been telling you that uh, if you take a cube, right, start with 10 square side, side equal to 10 square, area is equal to 10 raised to 4, volume equal to 10 raised to 6, and you combine it with some other 10 square, and this becomes 10 raised to 8. This becomes 10 raised to 8. I always explain about this. Right? In here, it doesn't. This is basically the quantum world. Quantum, yeah, let's say. And there is this. Similarly, there is this relative realm where this is C, this is C square, C cube is this, and we have take another C, and this becomes C4, right? So, yeah, C4. This is 10 raised to 8, this is C4, and I always argue that, let us rub it out a bit. I always used to argue that uh, Einstein, Einstein's tensor, representation in tensor form, mu is equal to gravity tensor c raised to 4 into t mu, right? We took 4 by 4 tensor, right? So here I always used to say that instead of this, the elegant solution would be taking 12 pi g by c6 into t mu mu, right? Why I'm telling you, why I explained a lot of times. Why? Because you take Pascal's term, let's say this is 11 raised to 0, 11, 11 square, 11 cubed, 11 raised to 4, 11 raised to 5, 11 raised to 6. Here I associate this with 3 into 10 raised to 8, that is c square, c cubed, c4. Root c, 4th root c. That is how I envision the quantum world. Till here, it is the quantum world. If you are new, watch my previous videos, then you will know what I'm talking about. Relativity starts from unknown, quantum comes here, and why I said we should take C6 is that Einstein took C4, he covered till here C4, but that C4 doesn't have C5, C6. The border of quantum and relative worlds is like c square, c cube. If you want to include both c squared and c cube, the common denominator for 2 and 3 is 6 denominator, common denominator, least common denominator. Right? So if you take C6, this C6 will be both C squared cube equal to C cube squared. You can do it even here, what do you call 10 raised to 6 if you take is equal to 10 squared to equal to 10 cube squared. Right? So minimum quantity that you need in terms of speed of light or in terms of distance uh, is power of 6. So if you take c raised to 6, then you will it will cover both. You see this, if you call this mass, if you call this a wave, then it will have both wave and mass. C raised to 6. In one unit, you will have both wave and mass. I mean particle rather. Particle. Particle wave duality who can coexist at c raised to 6 or 10 raised to 6. Yeah. Got it? Now, this, let me wait. Then we'll go to the next step. Now, so now 3 raised to 6 is equal to c squared k c k squared. That is, this contains both wave particle. So this c raised to 6 is something like carbon carbon atom. Right? And I also earlier explained about my own theory that the what do you call the, the waves are in form of squares 1, 4, 9, 16, 25, 36, and so on. 40, 60, like so. And this one is not a stable element. I told you it is not a stable element. So it becomes helium, unstable, stable. 1 becomes 2, 4 becomes acquires 2 more to become 6, 10 takes 1 more and becomes 10, 9 takes 1 more and becomes 10, 16 takes 2 more and becomes 18, this becomes what takes 1 and becomes 26, it becomes 38, this becomes 50, this becomes 66. These are basically nothing but the elements. Elements. These are elements. And in the sense, when I say elements, the elements will be naturally be stable. Even hydrogen is stable, atom is stable, and all that. But when you take only ion, it is not stable. So it tries to acquire another electron and become two, and thus stabilizing its configuration. So this goes on happily. So we the quantum world is like this hydrogen atom. 118, 119, 120, 121, 122. Let's say this is the periodic table. All the elements in periodic table. This is like the proton of next periodic table. This is neutron of next periodic table. This is hydrogen atom of next periodic table. This will be like helium of next periodic table. So this hydrogen one becomes helium 2, that to become stable. This hydrogen already has 119, 120, it is 121, right? This tries to become this. This will also have 119, 120, 121, two 121s, right? Two of such hydrogens will become helium. So this is kind of quantum world. This is the quantum world. But it goes, if you take Aufbau principle, which I expressed last time, 1s2, 2s2, 2p6, 3s2, 3p6, 3p10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, let me stop here, 6s2, 6p6, 7s2, 7p6. Exactly. Indeed. Here, 5, yeah, 50. Yeah. So, according to alpha principle, it goes on filling like this. Electrons go on filling like that. And at the end, we have 5f4 and 76, f14 and 76. So, this completes 198. So, where should the new guy go? Then, I told you, the new table will start with uh, 121, 190 will be total, 120 will be next one, 121 will be new first element, 122, and here 121 plus 117, that is 298. 298th element will be here. Right? So, what I mean to say is the new table starts with 121 and ends with 298, and this is like 121, this is like 122, this is like 124, this is like 126. I am stopping here because the supersymmetry ends there. This because we are not interested in basically the whole of the second table, whole of the new periodic table. What all we are interested in is only in this step, because this c raised to 6 is both the cube and square and cube. Here at this stage, that is the carbon atom of next periodic table. At the next carbon atom of next periodic table, the present whole uh, symmetry ends. So, if you take this as 119, let's say, if you take 4 such 119s, if you take 4 such 119s, club them together, it is not painting a very good picture there. I would rather draw it as rather than draw it as which will be more clear. This is 119, this is 119, this is 119. 119 is a cube of pi r cube, right? If you take in 4 such pi r cubes, you will get 4 thirds pi r cube, which is volume of sphere. And I also, in the last video, told you that this is like the graviton. Graviton, in a way, you can say here we have 124. Now you know what I'm driving at, I hope. These elements tend to become stable. This 122 is quite stable. This is the 122, which is which has 118 elements, 119 proton, like 120 neutron like. That is 121 is hydrogen atom. And you can stop here. You can also say 4 into pi r cube by 3. This such 4 121s, if you take, it will become 124. This 124, I told you, is like the graviton, which is a force carrier for the particle that you can't call it Higgs field, but let us say supercarbon. This 4 applies energy to. This is somewhat like CH4 method. These 4 hydrogen atoms supply energy to carbon, form bonds with carbon atom, and they form a very stable structure. This is basically the supersymmetry. Why only carbon, not others? Then this is the logic. This can be both a wave as well as a particle C6. So this C6, uh, the energy is supplied by 124 to this C6, and this becomes a supersymmetry. That is the reason why uh, the what do you call till here, each of these is quantum. Quantum 1, quantum 2, quantum 3, quantum 4, let's say, reals. These quantum 4 coordinate 4 quarters. This is simplification actually, because 4 cones perfectly make one sphere, meaning they won't be looking like this. They will be mingled, twisted, and form a sphere. So, 4 quantum realms are contained within this 124, and this 124 provides energy to C6, and that is why we need uh, uh, till here till here we have 4 quantum numbers, principal, um, azimuthal, magnetic, spin, right? With using these 4 quantum numbers, and how, what is p here? P is the last p we used is 7. Seventh principal quantum number is the last one we used in the this whole thing is quantum real. Right? We used 7th principal quantum number. Rest of the things are almost same. So at the 7th level, it filled, and we got the whole quantum world. So till here it is quantum world. Here, this is basically the new periodic table. Let's say in the new periodic table, these are all super elements. Let us say. These super elements, this contains 2 of these, this contains 4 of these, right? So these four support energy, supply energy to C6. So this becomes the what do you call that? Um, we have is hybrid, hybrid um, real. Let's say this is the border of these two. This is where quantum 1, quantum 2, quantum 3, quantum 4 all make the image. Yeah. Right? That is why I said we should take G mu mu is equal to 8 pi G by C4 T mu mu. Instead of this, we should take 12 pi by C6 T mu mu to accommodate this. Why? If you take 10 square and rather than 10 square then take 1, yeah, 10 square, 10 raised to 4, 10 raised to 6, 10 raised to 8, and with 10 raised to 8, not just that, you can as well say 10 cube, 10 raised to 6, 10 raised to 9, 10 raised to 12, let's say. So the fourth dimension will be here the 12. So when you follow my videos, I always tell you about how we got that 2 pi r first we integrate, then we take 4 pi r squared, we integrate, then we take 6 pi r, 6 4 pi r cube, we integrate, we ended up with 2 pi r 4. If we integrate 6 into 4 pi r cube 2 times, and this will become, we get 2 pi r 4. Fourth, fourth, fourth dimension. So, for that reason, you should not stop at 8 here. You should go beyond 8, uh, let's say, uh, let's do 10, yeah, 10 square, 10 to 6, 10 to 8. And if you go on the limits like that, 1 will be 10 to 10. The whole thing will again that will become 10 raised to 12. That 12, 10 raised to 12 you should take, and 10, 12 pi by c raised to 6. If you divide this whole thing by 12, this thing, energy by C6, then you will get what do you call the perfect um, hybrid system. So to do all that, what we need, we have already uh, covered till here we have covered till 118, and this was the seventh principal quantum number. So to cover the next one, and I mean the next periodic table also, what do we need? We need um, 8s2, 8s2, 8p6. We have covered till 7s2, 7p6. We need 8s2, 8p6 to cover the next periodic table. The first 6 elements of next periodic table you want to cover, you will need another quantum number. Okay, so we have covered till 7s2, 7p6. This is called organon, I think, organon, organon or organon. I don't know. That's a 118th element. 118th element is this one. So if you want 121, element 121 and 122, these are like, this is like hydrogen, this is like helium, not 122. Let's say carbon 126. Till 126 we want the methane. Then what kind of, how the configuration will change? 8s2, if you add plus this 8s2, that will become 120 plus 8p6, if you add this will become 156, isn't it? So if you forget about helium now, this will become 126. So principal quantum number, what is the principal quantum number of this? 8. Isn't 8 principal quantum number? 8 will be needing. And since this P8 is not part of first periodic table, it is not part of first periodic table, this is the second periodic table, we cannot call this the quantum world, quantum realm ends with 118. This is the relative realm starts with 121 and 298, ends with 298. So this is, you cannot call this principal quantum number, though it is, uh, I mean, logically is the eighth one, eighth principal quantum number. You cannot call this a quantum number at all. So we need, I call this relative quantum number. That is first relative quantum number. That is, so everything including, you see, we start with Newtonian mechanics, then we have Lagrangian mechanics, we have Hamiltonian mechanics. None of these mechanics include this period. They don't include theory. So, to include theory in the quantum mechanics, we are going to take only theory. In the relative mechanics, that's in the word, let us say, relative mechanics. Mind you, relative mechanics is not same as quantum mechanics, no, and Newtonian mechanics, not quantum mechanics. This whole thing of quantum mechanics. In quantum mechanics, we use Lagrangian, Hamiltonian, all this. Basically, Q what is QFT? QFT is nothing but clubbing Newtonian mechanics and quantum mechanics, right? Quantum part, representing quantum in the form of classical fields is what QFT is, right? And so This relative mathematics means one more quantum number. And unless we include that quantum number, we cannot account for rather unify to unify quantum and relative realms. We need one more quantum number. That is eighth principal quantum number. And along with eighth principal quantum number, only just principal quantum number does not define the whole system now. So because azimuthal azimuthal is gives you the angular momentum, uh, magnetic quantum number, quantum number gives you projection of angular momentum. So and is a relative quantum number. Relative quantum number will give uh, rather um, uh, angular momentum of angular momentum. And definitely you will need to fill the electrons even up to 6 c raised to 6, that is 8 s to 86. You need all the three. So you need principal quantum number, azimuthal quantum number, analytic quantum number, is all relative. Relative quantum number, relative principal quantum number, relative azimuthal quantum number, relative analytic quantum number. You need because this is the principal, and to come up with S energy of S and P, you need azimuthal again. So a combination of these will have to be defined, meaning we need to define um, quantum numbers, set of quantum numbers plus set of relative quantum numbers. We need to define the whole system. This is this is the quantum world. This quantum world is going around another object here. So this the moment of this will be like one will be like we use the uh, principal quantum number is the number of orbits, and these will be giving like angular moment, what we can W omega r, okay, omega r. The other one gives you the one more angular momentum like omega r or something. The other one, the magnetic quantum number. All these numbers are this whole world is quantum. But is it like something like when we repeat this is one moment, this is another moment, this is the third moment, right? All of these, that structure is revolving around. So one more quantum number at least to define the angular momentum of quantum world, quantum realm around relative, relative C6, let's say. This P, this quantum world revolves around uh, graviton. Graviton revolves around this C6. So, how many you need? Whole new set of quantum numbers. The present number of quantum numbers are not enough to define the angular momentum of quantum world around the electron. So, I think, uh, as usual, as I always say, I'm not a good mathematician. I'm not a mathematician at all, I think. So, uh, what I say is there is a whole lot of math that needs to be worked out using the Lagrangian and Hamiltonian of the quantum mechanics. And basically, what we need to do is, uh, what we need to do is include uh, another new set of quantum numbers. I don't know what the implications are for um, the Schrodinger equation, Schrodinger equation, and Paul-Dirac equation. Uh, how they will change if you add new set of quantum numbers. I'm not really sure. It's for the mathematicians. I am just a pure, simple physicist. Right? That's no. Physics, yes. That's my principle. But obviously, unfortunately, you need math to correctly define the system. And my conclusion is for today is that we need we definitely need a set, a new set of quantum numbers, or even one, two, instantly arithmetic. Not just it will not do. Principal quantum number alone will not do. We'll have to have technical also. So at least we need to have a new set of at least two relative quantum numbers along with this. So I don't know the implications that we can have on Dirac's equation and Schrödinger's equation, but that's for the, our brainy math, math, mathematicians. Right? So I leave it to them, but meanwhile I'm trying to come up with something and then some simple math. And yeah, that's all for today. And we'll meet some other time and talk in the week also. Until then, bye. Thanks for watching my video. Uh, as I told, we'll meet makers. Thank you.